Hello, my name is Jonathan Guidry. I was the Group 1 reporter for the engine performance experiments. And just an overview of the presentation. I'm going to give a couple objectives of the experiment, then a little background on internal combustion engines, then go through the procedure for the constant load, variable speed, and constant speed, variable load experiment that we performed, a couple of comments, and then my references. Alright, so the objectives of the experiment was to show the variation of engine parameters for two certain loading conditions. That was horsepower and torque that we really were concerned with. The two loading conditions were 4 constant loads where we varied the throttle, then a constant speed where we varied the load. Just background on internal combustion engines. Basically, it's just an engine block with one or more piston cylinders that's connected to the crankshaft, and fuel comes in and it's combusted and expands and it drives the crankshaft, and that's where we get mechanical work. And they follow the spark ignition engines follow the Otto cycle, which is the ideal cycle for that. Our engine that we're using is a single cylinder 4-stroke engine, 420 cc, I believe. And this is a little animation of 4-stroke. You got the intake where it sucks in the air, then it compresses the air, heats it up, and it sparks the fuel and air mixture, expands, also called the power stroke, and then it goes through the exhaust stroke. On the right, the top graph is the real cycle, and the bottom is the ideal. As you can see, right here is where it really shows the isentropic expansion and compression. These are a couple of the equations that we need, the calculations. Alright, so the procedure for the constant load, basically we just start up the engine, let it idle for 5 minutes, make sure it warms up, set the data rate to 200 hertz, and then open the throttle. Each time we tested it, the data was collected for 5 seconds, and that was for 0 load, 10% load, 20% load, and 30% load. For constant speed, the engine RPM was set to about 2,500 RPMs. It kind of fluctuated, but that's just going to happen because it's a cyclic engine. Data rate was switched to 10 hertz for that one, and the load was increased every 5 seconds with the constant throttle from 10 to 40% load, and then after that it was shut down. Alright, so this is for the constant load, the horsepower versus RPM. The lab manual said that there's probably going to have to be some doctoring of the data, which you can see like up there. It's kind of does some crazy stuff. I think that was because sometimes the power would keep increasing even though the RPM was dropping at random spots. I'm not sure why it was doing that, but that's what it was doing. This is a torque versus RPM. As you can see, the data was doing the same thing, kind of, but one important thing to note is if you compare horsepower versus torque, horsepower continues increasing, but somewhere around between 1,500 and 2,000 RPMs for each case, torque dropped off, and that's because whenever you get to certain RPMs, the airflow starts introducing losses, but horsepower is torque times RPM, so it still increases. Alright, so then for the constant speed, variable load, it was set to 2,500 RPM, and each of these steps is the different 10% loads that we increase each time. And then calculations. We needed to calculate the mass flow rate of the air, volumetric efficiency, the fuel conversion efficiency, and mechanical efficiency, and the BMEP. So basically what I did was this plot of data. I just kind of found one set of data points, found the air-fuel ratio and the fuel mass flow rate, and using the first equation, found the air mass flow rate. And then from there, went to the volumetric efficiency, fuel conversion, just kind of went down the calculations. And the BMAP, that is kind of a theoretical value. It's the theoretical pressure to push the cylinder down to produce the indicated power. A couple of comments, the load valve readout was not working, so we just kind of had to, each click was a certain percent load that we went by the manufacturer's recommendation. So we just kind of went through that. So that could have also been why the data was kind of fluctuating at that spot. These are the references, and any questions?